Now we shall see the mechanism of beta adrenergic receptor. So this diagram shows a model of how the beta 1 and beta 1 and beta 2 receptors are activated. Once the neurotransmitter norepinephrine binds with the beta 1 or beta 2 receptor, it is made of a GS protein, G protein and S type. Okay, this activates adenyl cyclase. This activates adenyl cyclase enzyme. This activates adenyl cyclase enzyme. Now, this adenyl cyclase is involved in the conversion of ATP to cyclic AMP, which activates phosphokinase A enzyme, and ultimately the calcium entry exit is controlled and thus produces contraction of the innervated muscle, smooth muscle, innervated smooth muscle. Okay, so this is the mechanism of beta 1 and beta 2 receptor. Only thing is this beta 2 is slightly different isomer of G protein, and this is again another type of G protein. Okay. So this is the second type of image that shows how beta receptor is innervated, beta 1 and beta 2. It is adenyl cyclase that is being involved, and beta 1 is having GS protein and it is having GI protein. Both of them is activating the adenyl cyclase. Both of them activating the adenyl cyclase. Then cyclic AMP is produced. Then phospholipase action, which triggers the entry of calcium, and that is leads to the calmodulin mediated contraction of the smooth muscle. So this is the next different diagram which shows how the contraction of smooth muscle happens with the innervation of beta 1 and beta 2 receptor. So it is just don't confuse with this diagram. It is GS protein, ATP, adenyl cyclase, phosphoinositol phosphorus, then this is both are common for this, and that leads to PLA activation and production of calcium, and that leads to contraction. Okay, so with the three different pictures, you just watch the how the G protein coupled mediated smooth muscle contraction, and it is innervated by norepinephrine.